Hello friends, how are you? Hope all of you are doing well. In today's lecture, we are going to study about a little bit about TDM, that is also known as time division multiplexing. TDM, that is the time division multiplexing. We are just going to study it for lab purpose only. That means we are not going to in depth analysis and the equations, etc., etc. We will just gain some basic knowledges about TDM and some more topics that will be very much useful to perform the lab experiment in TDM. And now at last we will also see the block diagram of TDM as well as the trainer kit of the TDM in pictorially. Okay, so without wasting any more time, let's start the video. Now our course outcomes are these. These are our course outcomes. That is, in some systematic order, we will follow the study or the description of TDM for our laboratory purpose. Okay. Now, the first we will see what is the multiplexing actually, and what is the need of multiplexing, why it is required, and how the multiplexing have discovered, what was the first need of the multiplexing, how we are getting benefited about it, we will see it. Now we will see after that several types of multiplexing, what are the multiplexing techniques that is generally used in communication system, that may be analog communication or digital communication, whatever. And later then we will see our main topic, that is the TDM. There is another multiplexing technique that I will show you, that is FDM, but in this topic we are not actually concerned about it, we are concerned about the TDM. Then we will see the block diagram of multiplexing. Basically the multiplexing I am going to show over here, that is the TDM multiplexing, that is time division multiplexing. For time division multiplexing, we will see the block diagram of multiplexing. For demultiplexing, this is also for the TDM demultiplexing block diagram and working we will see. And then we will see an example. This is the most important here, because in engineering field, any topic that we are going to study, obviously that must have an example in our real world. So I will analyze this TDM with an example also, and at last we will see the trainer kit diagram, that is the experiment that we will go to perform in our lab on the trainer kit, how that trainer kit looks like, and what is the input, what the output will be given, how the measurements of several parameters will be done. We will see it later. So let us start our first topic, that is what is multiplexing. What is multiplexing? Basically the need of multiplexing that are going to study about here. What is the need of multiplexing? See, suppose you and your friend. Suppose you and your friend. I am going to give about the idea of the multiplexing through an example. So suppose this is you, this is person 1, and this is person 2. These two persons are going to communicate through a same channel. These two persons are going to communicate through a same channel. This is a channel. Now why the same channel concept has coming over here? Because you know that the voice frequency lies between 300 hertz to 3 kilohertz. So as voice frequency lies between 300 hertz to 3 kilohertz, so a channel bandwidth must have this 300 hertz to 3 kilohertz, that is the 3000 hertz bandwidth. Our channel bandwidth must satisfy this frequency range. This is the frequency range. Why? So that we can communicate our voice signals, communicate from one end to another end with our voice signal. So this is our channel. Now the thing is, you will observe that several people had several voice frequencies. Suppose this person is talking, this person is communicating with the 500 hertz frequency, and it may happen that the other person that is communicating with some other person through the same channel may have the 650 hertz frequency. So as you see, the voice frequency that these two person are using are different, right? But both of them are using the same channel to communicate at some other end with some other persons. Now the problem arises in this channel. What is the problem actually? Problem is, as these two frequencies are different, the receiver for this person 1 must receive the 500 hertz frequency to retrieve the message of the person 1 that the person 1 wants to send to the receiver. Similarly, for receiver 2, the frequency must be 650 hertz. That means in transmitter end and in the receiver end, the frequencies must match with each other, so as whatever this person 2 are communicating through a channel, that must be detected easily by this receiver. Now, what about the channel story? For these two person and the two recipient, within the channel, two frequencies or two messages, 500 hertz message that is denoted by message 1 and 650 hertz message that is denoted by message 2. Two messages are going to propagate through the same channel together. Why? Because both the person are using a single channel. Why the single channel? Because the voice channel that we use must have the bandwidth, has actually the bandwidth 300 hertz to 3 kilohertz. That is whatever, not only for two person, every person in the world that is communicating through a same network, that is if you are using a Geo network or if you are using a Airtel network, the Airtel network has many number of subscribers. Thousand and thousand subscribers are using this Airtel network, and they all are using the same channel, but the frequencies or the voice frequencies that they use to communicate, their own personal voice frequency that they are used to communicate with the other end is totally different from each other. Even that may completely same also, and most of the cases that are different. Because if you notice carefully, if you have some idea of music, and this is the another idea, so this is not inside the note actually. So if you have idea of music and if you like to play guitar, you may observe that the acoustic guitar has the 6 strings: C, G, A, B, C, and G minor also. Okay, there is the first string to last string, 6 string. I can remember the exact name of this string, but whatever, the first string pitch is very high. That is the frequency. If you just tone this first string, if you just hit the first string, the frequency that this first string will generate is very very high. And similarly, the last string of if this last string is vibrated by your finger, if you just play the last string, then the frequency that the lasting will generate is very very low, and in between the frequencies are just increasing from left side from sixth string to first string onwards. That is the frequency is increasing, F increases. If you have some knowledge about guitar, then you can see over it. Now the basically the boys that they talk, the the frequency of the throat of a boy generally lies between C scale and G scale. Basically these two scale are for boys, not boys, sorry, boys. But the girls, if you measure the scale, I will show you in the college that the girls communicate in these two scales, that is B scale and the C scale. That means the pitch of the voice of a girl is very much high than the pitch of a boy. That means the frequency that is generated from the from a girl's voice is very much higher than the voice that is generated by a boy. Okay, so that's why the some of for the voice of some girls are very much irritating. So don't take it other way. So basically I am going to just show you that several person, depending upon their voice, depending upon their tone of their voice, several person may have several frequencies. That means if a boy can generate frequency up to 1000 hertz, a girl may have generate up a frequency up to 2000 hertz also. So that is the main problem. The same channel, multiple users are trying to communicate. Why multiple users are trying to communicate? Because the communication is going to done in the voice frequency range only, and the channel has same the voice frequency range. Since the channel has the voice frequency range, that's why the channel is same, and through the same channel not only two users, multiple users are trying to communicate. And there is a problem, because if we don't do anything, that the multiple frequencies will overlap with each other within the channel. So what about this channel? So what about this? Basically, if you don't do anything, there is the low frequency and the high frequency will be overlapped with each other. So detection will not be possible. Detection not possible. So this is the frequency overlap. So this is not actually within the study unit, so just ignore it. That is the frequency overlap. So for as these frequencies are overlapped, these frequencies are not very much easy to detect in the receiver end. So the receiver for this person P1 will receive mixed frequency. That means it will receive some noise along with this voice, along with the message that the P1 has sent. The P1 sent for this receiver. Similarly, same will happen with receiver 2 also. And that's the main concept of multiplexing. That's what the multiplexing comes. Multiplexing says that, what is the multiplexing says? Multiplexing, it says that it sends multiple messages. It can send multiple messages through same channel, through same channel, without any disturbance. Now how the disturbances are eliminated, we will discuss it later, but for now just see that the multiplexing is such a technique through which we can send multiple number of messages through a same channel, and no message will disturb with each other. That means at receiver end, each of the messages will be discretely determined. That is the multiplexing, and that is the need of the multiplexing that I have already discussed over here. Okay, and with this our first topic is complete, that is what is multiplexing. Now we will see what are the types of multiplexing, because basically The multiplexing in digital communication has been divided into two types. One is TDM, that is the time division multiplexing. Multiplexing. And one is FDM, that is the frequency division multiplexing. The one is time division multiplexing and another one is frequency division multiplexing. Now, in this topic, we are not concerned about the frequency division multiplexing. We will briefly discuss about the time division multiplexing. But just for information, I will show you the basics of some that is the some just knowledge of this frequency division multiplexing. See the story carefully. The story is the signal that we are going to propagate, that we are going to send, is nothing but a high frequency signal, right? So whatever the signal that we are going to send is sinusoidal or cosinusoidal carrier signal that is modulated by several parameters of our message signal, right? That means we cannot send actually the digital signal direct. We use some carrier signal as well. Now, there are several types of carrier signal that are going to generate from several users. That is the multiple users. Multiple users can generate multiple carrier signals of multiple different frequencies. If we manage some technique that we can alternatively transmit this message signal based upon the frequency, that is message alternate MTs when message signals are transmitted based upon their frequencies. That is the channel is fixed. Okay, that is, you can see here the channel is fixed, but as we have to transmit multiple message signals of several frequencies, several different frequencies, that's why we are going to implement such a technique that the multiple frequencies will be alternatively sent from sender to receiver through the same channel, right? So that means that's whatever I have written here, that is the multiple message signals have the multiple frequencies, and multiple message signals are transmitted based upon their frequencies alternatively. Okay, that is the sequentially we are going to transmit the message signals, but we are dividing the message signals based upon, we are selecting the message signal based upon their frequencies. Whatever, I am not going to discuss about the FDM, just for knowledge I have written the definitions over, or the meaning of the FDM over here. But our concern is TDM, that is our third topic. There is a TDM. TDM, listen carefully, TDM is also called time division multiplexing. If you see the name carefully, the name itself suggests that the multiplexing is divided in time domain. That means I think that this line may not have to clear to you. I will make it clear, and at the end of this session you will make it clear on your own also. This is the magic of today's lecture. So whatever we are going to done over here, the criteria or the phenomena is same. That is there is a single channel. Okay, let me draw this diagram. So there is a single channel. Okay, this is our channel. but there are multiple users that want to transmit their messages through this same channel. Okay, and they are, each of the messages have their own destinations as well. Okay, so all the users, that is message 1, message 2, message 3 and message n should be transmitted over a same channel. Now whatever we have done over here, that is we will alternatively select single messages to transmit this channel. That is, let me show it clearly. That is, suppose there are multiple messages, message 1, message 2, message 3 and so on up to message nt. There are multiple messages as you can see over here, and multiple messages has been generated from, this is user 1, this is user 2, user 3. Okay, so similarly like user 8, multiple messages has been generated, and all of the users want to transmit the multiple messages through a same channel. Okay, through a same channel. This is our channel. We want to transmit the multiple messages through this channel. So whatever I have done, suppose I have made a selection circuit, that is the selecting circuit over this selecting circuit has been fitted over this portion, that is the before the channel, before just pushing the messages into the channel, there is a selective circuit that is shown over here, and this circuit is also called, and the circuit is also called the selection circuit as well as, and basically I will see this circuit in the block diagram part in details, but for now this circuit is called commutator. Okay, this circuit is called commutator. The circuit is the circuitry that will be attached over here just to select the message signals alternatively based upon the time. This is also called the commutator. This is called the commutator. And what is the purpose of this circuit? What is the working of this circuit? This will alternatively select the message 1, message 2, message 3, message 4 and up to message n so as to transmit over here. That means if at t equal to 0, message 1 is selected, then t equal to 1, message 2 will be selected, t equal to 2, message 3 will be selected, and so that t equal to n minus 1, message n will be selected. That means what are going to do on over here, basically we are going to do message 1, message 2, message 3. We are going to send the message 1, message 2, message 3 and so on, message n at several time. That is, we are dividing the time actually. We are making a frame. Okay, basically we are making a frame, and each frame is going to transmit several times. That is, this frame is going to transmit the t is equal to 0, this frame is going to transmit t equal to 1, this is t equal to 2 and this is t equal to n. That is 0, 1, 2, 3 n. There is a clock, see, there is a clock, and the purpose of this clock is just to transmit multiple message alternatively through this channel. So what the clock is going to do, this is the selecting the messages. it is 1 2 3 4 5. If CC there are 5 number of messages, then what it will do, 1 2 3 4 5 again, 1 2 3 4 5 again, 1 2 3 4 5. That is the, it is the repeating the same manner. That is the, this thing is repetitive. This thing, this process is repetitive. There is the circuit that is fixed over here. There is the repetitive. You will be more clear cut, you will get more clear cut idea when I will show you the block diagram actually. But for now, just to understand the TDM, okay, that is the, we are basically multiplexing. We are sending many messages through one channel. Multiplexing means many to one. So we are sending many messages through one channel just by dividing the messages in terms of time. That is, we are selecting the messages in terms of time. If we select the message M1 at t equal to 0, then M2 at t equal to 1, then M3 at t equal to 2, M4 t equal to 4, M5 t equal to 5, etc., and at Mn will be selected at t equal to n. After selection of all n messages, after sampling of all n messages, that is it, at t equal to 0, what it is going to do, actually at t equal to 0, it is sampling the message signal. Sampling means it is allowing the message signal for some time. For some time there is a little bit delay, that is the delay time. So for some time it is allowing the message M1 to transmit through the channel. Then after the delay is over, at m equal to 2, at the t equal to 2, the message 2 will be transmit for some time. Then after the delay is over, message 3 will be transmit for some time. That is, within the t time interval there is a little bit delay, that is the called time delay. And what the delay, what is the purpose of this delay? Throughout TD time, throughout the TD time, one single message will be transmitted. Okay, throughout the delay time, a single message will be transmitted. That is, what is the delay? What is the purpose of this delay? Basically, up to TD time, this clock, this commutator is allowing the message 1 to transmit. That is, the message 1 will access the channel only for this TD time. After TD time, the switch will be shifted to message 2. Then the message 2 will be able to access the channel. Message 2 will be get attached to the channel to transmit its message only for this TD time. After TD time, again this clock will be shifted, and in this way this procedure will continue. Then at the channel, this is through channel, what I will see, the several message signals sampled at several times has been transmitted through like a frame. Okay, just like a frame. There is the multiple frame of messages are being transmitted over here at this single channel, but they all are transmitted at several different times. There is at 0th second, M1 has been transmitted, 1 second, M2 has been transmitted, 2 seconds, M3 has been transmitted, and similarly Tn minus 1 second, Mn has been transmitted, etc. Okay, now the thing is, we will see the block diagram of TDM multiplexing and demultiplexing together. That is, we will see the third and fourth together, so as to understand what is going to be done here. See, our message signal, okay, the message signal, that is the voice signals, that is the low in frequency. Low in frequency means whatever the carrier we are going to transmit, basically this is in a kilohertz range. Okay, so carrier is kilohertz range, so that's why this is also called, we can say this is low. Why low? Low actually with respect to noise. If any noise is attacked, that is the if noise is attacked with carrier. If noise is attacked with carrier, then this may be a high frequency signal. This may be a high frequency signal. Okay, so just to transmit a single message through the channel, we have to put some circuitry just before the transmitter, before the merging the messages through the channel. We have to put a circuit, and what is the circuit? There is a filter. Now we will see the block diagram. There is a M1T message, one message, second message, third message, and in similar way I have suppose nth message, and each of the messages will be passed through ILPF, that is the low pass filter. Why low pass filter here? Because just before the generating, after the generating of the message, if the message is attacked by if the message is attacked by the noises, then the noises will be removed. Okay, then the noises to just to remove the noises, we have put a filter over here, that is the low pass filter. What is the low pass filter is going to do? The characteristics of the low pass filter is just like this. It is the allowing the lower frequencies and blocking the higher frequencies. That means if the noises are attacked by these noises will be removed. Remove noise. So just to feed the original signal, original low frequency signal, that is the without noise, the pure signal will be fed to the channel. Then after that, what is the circuit will be present over here? That is the commutator. Okay, this is the commutator. Okay, what is the commutator is going to do? Commutator is accepting the allowing all the message signals alternatively. This is the allowing all the message signal alternatively, that you can see over here. Basically it is selecting the message signal alternative. As you can see, there is a clock, there is a clock hand, just like looks like a clock hand. Basically this clock hand is shifted from at 1, this clock hand stays at 1, at 2, at 3, 4, 5, 6, 7, 8, 9, 10, up to n number of messages, nth message, for some time, and this process is repeated again and again. That means if this commutator, this is called the commutator, this is called the commutator. Now the story of the commutator that we will see over here, story of commutator. Story of commutator that you will see over here, that is commutator. What is happening at t equal to 0? Suppose at t equal to 0, that is the 0th second, the commutator is connected with the message signal. At 0th second, the commutator is connected with the message signal. That means the message is allowing, this M1 message is allowing to pass through the channel. Okay, this M1 message is allowing to pass through the channel. This is our channel. Okay, this is our channel. The same one message is allowing to pass through the channel at t is equal to 0th second. But the thing is, you must have to remember that for how much time the message 1 will be allowed to transmit through the channel. That is the TD time. Because what is the TD? TD is when the commutator clock, the commutator hand will be shift from t equal to 0 to t equal to 1, t equal to 0, t equal to 1. That is when it will connect it to the second message. Then the second message will be transmitted through the channel, and that message will also be transmitted for TD time. Similarly, same thing will be happen to the third message also. From second message to third message, when the clock hand will be shifted, then the third message will be connected through the channel. Then the third message will be transmitted through the channel only for TD time. Now the thing is, what is TD? TD is the delay between these two sampling time. Sampling time means actually at t equal to 0, just the delay between at t equal to 0 t equal to 1, the delay within which the sample, that is the clock hand will be shifted from here to here, from first message to second message. Within that delay, the for that delay, during that delay only the one single message will be transmitted. That is also written over here. That is the throughout the td time only one single message will be transmitted through a single channel. Okay, so we can say that the message 1, message 2, then message 3, in this sequence the messages will be transmitted through the channel. Okay, through the channel. In this sequence the messages will be transmitted. Now one more thing that is very much important, that is you can see that the message 1 is going to transmit it at t0, message 2 at t1, message 3 at t2, and message n at tn. Now what will be after t equal to n? At suppose at t equal to n the message n has been transmitted, right? In similar way, at t equal to n the message will be transmitted very easily. But after t equal to n the same process will be repeated. That means after t equal to n the commutator will start again from t equal to 0. That means after transmitting in nth message, it will again look up m1t, that is the first message. That means if I write over here, that is m1t, m2t, m3t. In similar way, once the total mn t, that is the n number of messages, has been transmitted, again it will start for m1t, m2t, m3t, and again mnt, then again m1t, m2t. In similar way it will continue. Okay, that means one set, after covering one set, that is from t equal to 0 to t equal to n, again jump to t equal to 0, it will again be automatically reinitialized from t equal to 0. That means this clock is actually just repeating its task again and again. That means after sampling each and every message after sampling, it will again return back to the first message and again it will sample each and every message sequentially, again it will back, and this process is will be done for infinite number of times, basically up to which these messages will stay over here, up to which one user want to send messages. Okay, so what is actually doing here, what is the commutator circuit actually doing here? Basically this commutator circuit is sampling the messages, and you know that after if you sample the messages, that is our PAM signal is generated, right? So as the PAM signal is generated, that's why in between the commutator circuit and the channel there is a modulator. This is called the PAM, there is the pulse amplitude modulator. There is a modulator circuit will be present over here. Okay, so it is very easy, it is not too much tough. Okay, basically what is going to done over here, basically this signal, this is the commutator, as this is a commutator, this is just like a switch, right? This is just like a switch. So just like a switch, it is the sampling each and every channels, and after sampling each and every channels, obviously the PAM signal will be generated, and just before entering the message, before sending the message, we need a modulator. What is the why modulator? Because you know that I have already discussed at the previous, that is we are not concerned to send the low frequency signals, we are going to send the carrier signals, not the message itself directly. Okay, now up till now we have sent the multiple number of messages, multiple number of voices, okay, multiple number of voices through a single channel. Up to this we have sent here. Now the process comes in demodulation. or demultiplexing. As this is very easy, that is, as modulation has been done over here, so similarly PAM demodulation will also be done over here. Okay, why PAM demodulation? Because up here we have received the carrier actually, not the actually message. No, now we need to receive the message, we need the message actually. So that's why PAM demodulation is being done over here. We need message, we don't need the high frequency carriers actually, we need the original low frequency message. So that's why the demodulation is being done. That is the actually in transmitter, and as modulation has been done, so demodulation is obviously needed in the receiver just to retrieve the message. Now again the same story is going to be repeated over here. There is an again clocking circuit, and what is the clocking circuit is do? Okay, this clocking circuit is named as decommutator, and this clocking circuit is, what is this clocking circuit is doing actually. See, I am going to show this portion in separately in a fresh page. So what is this clocking circuit is going to do? Basically, see, the message 1, from message 1 to message n has been transmitted together through a channel, right? From message 1T, M1T, M2T, M3T, these all messages has been transmitted together, but they are transmitted sequentially through a channel. Now as this total frame contains the n number of messages, but the thing, if you can remember, that is, this message has been transmitted at t equal to 0, this message has been transmitted at t equal to 1, this message at t equal to 2. Similarly, this has been transmitted at t equal to n, but all the messages has been transmitted together. From transmitter we are receiving these messages, right? That is, at receiver we are receiving this. But the thing that you should remember, that the timing the messages were sent was different, and the receiver must know the timing when the message 1 will be sent, message 1 has been sent, when the message 2 has been sent. So if the receiver want to receive the message 1, what it will do? It will just resample the received signal at t equal to 0. When it will check at t equal to 0 what is the message, if it checks the t equal to 0, the what will be the frame? In frame, all the other messages will be removed, all the other messages will be absent, only the message 1 will be present. That is, if we sample the total frame at t equal to 0, all the messages will be cancelled. That means the no messages will be present over here. At t equal to 0 we will find only the message 1. Similarly, at t equal to 1 we will find and message 2 only. At t equal to, just like as t equal to n, we will find the message n. That means, as we know that the messages has been transmitted together through the channel, but we also know that the message has been transmitted together in the channel but in different times, and the receiver know the times. That means receiver know that at t equal to 0 that the message was sent. Now it is quite obvious that if the receiver samples the received message at t equal to 0, then what it will receive? At t equal to 0, what was the message present through this channel? Only M1T, that is the first message was present in this channel. Okay, because at t equal to 0 only the first message was sent. So now if the receiver samples the channel at t equal to 0, then it will find that no other message was present in this channel, only at t equal to 0 M1T was present in the channel. That means at t equal to 0 only M1 was present in these channels. So at t equal to 0, first M1 will be received, then similarly M2 will be received, then M3 will be received, and up to Mn will be received. And what is the decommutating circuit doing here? It again it again starts its clock from t equal to 0 to t equal to n, and when it is repeating it is just driving its clock from t equal to 0 to t equal to n. The channel is sampling at every instant of the time. At t equal to 0 it checks the channel. Okay, in this channel now m1 was present, it just pull the m1 t back in the receiver. At t equal to 2 it sees that only m2 was present, now it pulls back this m2 towards the receiver. In this way, when this cycle is repeating again and again, all the message signals that was sent sequentially through the channel at the transmitter end, that is all the message signal that was sent sequentially through the channel from the transmitter end will be retrieved by the receiver. That is, at t equal to 0 this will be sampled. Okay, at t equal to 0 this m1 will be sampled, the channel will be sampled, and it will find that the m1 is present, the m1 will be output. At t equal to 2 m2 will be output, because at t equal to 2 the channel will contain only the m2 message, no other message will be present, so that is the m2 will be output. Similarly for at t equal to 3 m3 will be output, at t equal to n mn will be output. But again, just like as previous, it was repeating. Okay, it was repeating. Like similarly, this will also a repetitive nature. Repeat. That means after checking at t equal to n, it will again start from t equal to 0. That means it will again start to find the channel. What was the m1 message, what was the portion of the m1 message was present in t equal to 0. That means actually at t equal to 0 m1 will be received, the portion of m1 will be received, at t equal to 1 m2 received, t equal to n mn received, and after completing this task it will again start from t equal to 0. That is, it is a repetitive nature, it will repeat from t equal to 0. That means after retrieving all the messages for first phase, it will just run its loop for the second, for third, for fourth, for fifth time, and up to infinite time this loop will run. That is, the each and every phases from message 1 to message n will be received. Again for second phase the message 1 to message 2 will be received. Again for third phase the message 1 to message 2 will be received. Fourth phase, fifth phase, and this message will be continued to receive at the receiver end up till that time. Up till what time? That is that up till what we just transmitted messages. That means if for 10 seconds, actually if we transmit messages for 10 seconds, if we transmit messages m1, if one person transmitted messages m1 for 10 seconds, then the m1 will be definitely be received up to 10 seconds. And if we sample after 10 seconds, if we just continue the sampling, then what we will receive? We will receive that the m1 is equal to 0 actually at that time. Okay, so that's the process of the demultiplexing. Now again one thing happens over here, the most important thing is happen over here. This channel is very much dangerous. That means the noise, definitely it is 90% sure that the noise may affect this channel, and as the noise affects this channel, that the signal that was being transmitted to this channel will be affected also. And as noise is affected, after noise affection, what's happened with the signal? The signal contains the higher frequency. That's why again the low pass filter are needed in the receiver, just as to remove the noise, because low pass filter again will remove the noise and just pass the lower frequencies. As the lower frequencies, that is the message signal, are needed at the receiver, that's why the low pass filter are needed. What is the low pass filter will do? Low pass filter will again do the same job. It will just reject the higher frequencies and pass the lower frequencies. That's why the noise removed, all the noises are removed from this. Okay, the noises are removed from this. In this manner, so whatever we have done over here, we have multiple number of messages. Multiple number of messages means multiple number of users want to transmit their messages through a same channel. So what we have to do, we have to do with the multiplexing, definitely that is the many to one, and we have also to do demultiplexing, just to retrieve the message. Okay, the opposite task of the multiplexing, that is the demultiplexing. Okay, now in the multiplexing, whatever we have done, basically we have seen that the lower frequency message signal may contain the noises also, so that's why low pass filter has been attached, and we have attached the commutator just is sequentially sampling the message signals and converting the message signal in the PAM signals. And as the PAM signals has been generated, we need some modulation, because without modulation we cannot just transmit the original base signal through the channel, so we need some modulation. So that's why PAM modulator has been used over here, and this signal is sampling each and every message signal sequentially, and this is a repetitive nature, that is after sampling all the signals, after covering all the signal, it will start again from zero. Okay, now the after receiving the messages, that is the message train from the channel, how we will receive each and every, retrieve each and every messages, that is a very simple task. As the receiver send the message m1 t at t equal to 0, then definitely if we sample the channel at m at t equal to 0, then what we will receive, we will receive that there is no more messages, no other messages, only m1 t is present. Similarly at t1, t2, t3, t4 and up to t equal to n, the channel is sampled, and the channel, as the channel is sampled, and with that, at that time we will see that the at t equal to 0, 1, 2, 3, the consecutive m1, m2, m3 and up to n messages will be received. And again, before receiving the message, before using the message, or before sending the message to the final receiver, what is our main task? Our main task is just to remove the noises again, because throughout the channel many noises may occur. So just to remove the noises, we have to reject the higher frequency terms, because the noise, if noise is affected, if noise affects the message signals, then the message signals will become the higher frequencies. That's why we need to reject the higher frequencies terms. So that's why we have used the low pass filter over here. And this is the rejection, this is the message retrieval, okay, that you can say. So with this we have seen that how through a block diagram of multiplexer and demultiplexer, we have seen how the TDM, that is the time division multiplexing, is working. Basically you have seen here that the multiple messages are being transmitted based upon the division of the time. So that's why the time division multiplexing, multiple messages sending through a channel, that's called the multiplexing. Okay, the TDM means the time division multiplexing, that is there are two terms actually, time division multiplexing. Multiplexing means, what is the multiplexing means? That is the many to one, many to one, that is we are sending the multiple messages, through same channel but single channel. But what is the time division? The messages are divided with respect to time. The messages are divided or sampled with respect to time actually. Okay, now, and the example, that is our sixth topic actually, that is the sixth topic, sixth topic, that is already covered at the beginning. That is the person 1, person 2, that I have already covered the example. Now we will see our last topic, that is our tenor kit diagram. So before going to the tenor kit diagram, again I want to show you what has been done, what we have done over here basically. So remember that the same diagram, you may be little bit confused that where the low pass filter has gone, while the other circuitry has been gone. So what is actually going to happen over here, the same thing will happen in the trainer kit also. I will make you understand where the other things has been done. But before jumping to the trainer kit, I want to show one more thing. There is the sampling circuit. As you have seen that I have used the sampling circuit over here, where the clock, there is a clock, this is clock like hand, and this clock like hand is just selecting the multiple messages at different time. This is t equal to 1, t equal to 2, and so on. Okay, now how this clock is happening, actually how the clock is generating multiple pulses at different time. Basically, there is a IC, or the 555 IC, you know, that is very much popular to generate a square waveforms. Okay, this 555 IC is generating the square waveforms. Now what is happening over here, at each stage the waveform is delayed, that is t equal to t naught. Now this waveform has been delayed up to td, then it has been again delayed up to td, 2td, then 3td. As the waveforms are delayed, then you will see that at t equal to t naught the pulse was there, at t equal to t naught, t equal to 0 the pulse was there, but at t equal to 1 the pulse has been shifted over here, and t equal to 2, okay, the pulse has been more shifted over here. Okay, that means what we are going to do inside this circuit, this is not so much important, but for laboratory purpose, what has been done over the actually inside the trainer kit, that is inside the circuit there is a just simple clock generator, that is the 555 timer IC. Okay, and the timer IC is continuously generating the multiple square wave frequencies. We are just delaying the frequencies for a certain amount of time delay. This time delay is definitely what, that is the t0 minus t1, that is the time delay of in between the sample, in time delay in between the sample time. This must be equal to t0 minus t1, as well as t1 minus t2, as well as t2 minus t3, etc, etc. So the sampling time interval is the delay actually over here, and we are just delaying the pulse, we are just delaying the pulse. Okay, delaying the pulse for td time delay at each and every steps, and up to what this delay will continue, that is up to n steps. This delay will continue, that is at last stage the delay will be in td, right? At the last stage the delay will be in td. Now what is happening over here, as the positive pulse is triggered, positive pulse is applied in this commutator circuit, there is a switch between the switch in the commutator circuit, and there are total n number of switches. Okay, and n number of switches is connected, n number of switches is connected to the pulse generator. That is a delayed pulse generator, actually we can say that the n number of switches has been connected to the pulse generator, where the pulse generator is delaying the pulse sequentially just by n number of time delays. First it will delay the pulse for td, then it will delay for pulse 2td. When 2td will be delayed, then the switch connected to the t equal to 2 will be activated. When 3td will be delayed, then the pulse will attack at t equal to 3 over here, then t equal to 3 channel will be activated. In this way, here is the multiple switch that are activating by the triggering pulse, and that triggering pulse has been delayed by td amount of time delay. That is most important, what is going inside the trainer kit. Now I will show how the trainer kit looks like, and how the measurement actually has been done over there. So the generic trainer kit diagram will be looks like this. Okay, this looks like this. Don't look at the other components, I will just show you the main thing which I have to perform over here, you can see that there are digital signals, right? Digital signals that has been written over here, that is the digital signals. And if you see here clearly, that you will find there are 16 number of digital signals are present over here. That is 1 2, you just remember the sequence of the numbering: 1 2 3 4 5 6 7 8, just a zigzag manner: 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Why I have told this in zigzag manner? Because this hole is internally connected to the one terminal of the multiplexer. Similarly, this two terminal, this is the two pin, pin number or port number 2 has been internally connected to the second pin, that is the virtually connected to the second pin of the multiplexer. That's why the for 16 number of channels, the 16 in cross 1 multiplexer has been taken in the trainer kit actually. Okay, that means we can multiplex up to 16 number of different frequency signals. If you see clearly, each and every frequencies are different from each other. That means there are 16 number of different frequency signals has been generated. Okay, and for now for lab we will see that we will see the total procedure only for two signals, and we will repeat the same procedure for other two signals also. That is what, if we take this signal and this signal, what is this signal, what is the numbering of these signals? That is this signal means 1 2 3 4 5 6. We will connect a patch cord from this to this, and if we take these signals, then 7 8 9 10, we will connect to 10th pin, to the 10th pin of the multiplexer, and these two signals will be alternatively sampled, and the sampling time, that is the sampling time interval, has been decided by the 555 timer IC that is inside the trainer kit. Okay, that is the from output of the multiplexer. What we will see, well, actually it will be little bit difficult to see the output waveform, because you will see a continuous flickering in between these two signals. Okay, that means it is continuously sampling these two signals alternatively at t equal to 0, at t equal to 1, t equal to 0, t equal to 1, 0 1 0 1 0 1 0 1. Alternatively, what is happening over here? Alternatively, these two signals are sampling 0 6 10 6 10 6 10 6 10 6 10 6 10. Alternatively sample, and the timing circuit has been present inside the circuit, as well as you can see that no low pass filter has been present outside the circuit, because they all things are present, but they are present inside the trainer kit, not shown the outside, because they are not required actually. Okay, so this is the TDM output. Now to demodulate the signal, what we have to do, we have to just connect the output to the input of the demodulator, the demultiplexer. And remember that if we connect the 6 pin, that is the 6, if we want to demodulate the number 6 signal number 6 that was connected to the pin number 6 of the multiplexer, we will receive the same signal from the pin number 6 of the demultiplexer also. That is, the total pins are synchronized to each other. If we consider, if you just allow, if you consider pin number 6, that is the 6 channel number 6, that is like 120 kilohertz channel, then it will must be connected to the pin number 6 of the multiplexer, and from the pin number 6 of the demultiplexer only we will receive the signal, that is the digital signal. Same thing will happen for the signal of the other pin, that is the pin number 10. Therefore, pin number 10, what will happen? For pin number 10, we will connect the pin number 10 to the pin number 10 of the multiplexer, and this pin number 10, the signal number 10 will be received from the pin number 10 of the demultiplexer as well, because the total things of the input, that is digital inputs, signal inputs and the signal outputs, are synchronized to each other inside the trainer kit. So that's what. So what we will see, we will basically first see the waveforms of the 2 channels or 3 channels, whatever the channels we are going to take to perform the experiment. So we will see individually all the signals at the for the first time when we will start the experiment. Then we will connect the CRO probe here, and we will see how the multiplexing is going to happen. Basically we can't see basically our persistence of vision, that is our eye can't detect the fast triggering. Okay, so we will see that there are mixture of three types of signals. Basically these three types of signals are continuously alternatively sampling with each other. Okay, now the at the receiver end, whatever the pin was that was connected with the multiplexer, just from the same pin we will receive the same signal of the same frequency. We will just cross check this frequency, calculate the frequency. If this frequency matches with the input signal frequency, then we will say that our experiment is successful. And that was all about the TDM. Okay, and I have just make you understand the total TDM only for the laboratory purpose. Again I am telling, no need to worry about the what is the calculation, what is the theoretically. So just the little bit calculation, little bit introduction that I have shared with you. So that's all about today. Thanks for watching. Hope if you like this video, you can smash the like button and kindly subscribe my channel, so that you will be notified very soon when I will upload a new video. And remember that this is an education channel. Okay, so thank you everyone, good night, and we will see you later. Thank you.